Good morning. My name is Navjot Singh Gill. I'm an application engineer with Ally PLM Solutions. I want to welcome you to Ally PLM Lunch Bytes series. These sessions are designed to briefly explore capabilities within Solid Edge that are often overlooked. Today's session will be on mold tooling. If you have any questions regarding to the session, please write them down and send them via email. We have a lot of you online today, so you'll be in listen-only mode, so that we don't get any feedback from speaker phones. Once again, today's topic is mold tooling. So as far as the agenda is concerned, we'll briefly cover injection molding process as a couple of slides, and then we'll jump into an Solid Edge mold tooling. We'll create a new project, and we'll go through different steps. Now, as far as the overview is concerned, project can be divided into three parts: stationary, movable, and ejector housing. The stationary one is the one with injection side. So this is the side where the plastic enters the mold. So the cavity is on this side, and there's no ejection on this side. So the part must not stick to this side of the mold. So we take care of that with the help of either temperature control, or we can put draft on the part. The second section is ejection side. So this is the side which moves when the mold opens. It allows the part to be ejected. The core is on this side, and it contains ejector pins. So what happens, the plastic shrinks around the core, and with the help of ejector pins, and it's ejected out. All right, let's dive into Solid Edge and look how we and go into the process of creating mold. Now, mold tooling is an assembly command. So what I'll do is open a new template, assembly template here, and you will notice I have mold tooling on the top ribbon. Mold tooling is an add-on. So as I switch on to this this toolbar, you'll see the only one command is highlighted. So because I haven't created any project, so if I clicked on the icon, it asks me the name of the project. So what it does in the background is it creates a new folder for the project. So whatever files will be created during the project will sit inside this folder. So in this case, I'll just say calculator or. And other thing you'll see here is mold orientation. Now, orientation, depending upon the standard which you're using, it's just a vertical step. So if you want injection to be on the top, you'll see the default orientation where injection is on top. If you want to change, you can change it. And what it does is it places the injection to the bottom and ejection at the top. So here I just hit OK, and it will create a new project. Now it's asking us for a port. Now, as you can notice, if I go to file types, it says it can only open Solid Edge file. But in order to bring in other CAD format or a neutral format, what you have to do is open that format inside Solid Edge, save that part as a Solid Edge part, and you can bring that inside mold tooling. So here, what I'll do is I'll select this part and hit open. And it opens and gave me a small command bar. So what I can do here is I can do a little bit of analysis, and also I can do automated split. I can provide shrinkage, and also I can change the orientation. So all I have to do is just highlight the tab here. It will generate an automatic split of the part. Now, if I want a shrinkage, it gives me an option of uniform shrinkage and non-uniform. All I have to do is just turn that off, and I can give it a non-uniform shrinkage. The third option is changing the orientation. So what I can do with this is I can change the orientation with respect to XYZ direction. So here, if I want to change direction on the Z direction, I can just hit the angle, and it will do. One thing to note here is, as you have seen that the color changed. Now this color code, which you see on the screen here, is it shows the draft. So by that I mean it tells you whether it's a negative draft or a positive draft. So I can change the orientation, and our project is all set. All right, the next step is called the parting line. Parting line and parting surface, they are the most important steps in mold tooling project. So what I'm going to do is just select the parting line command, select the part, and hit accept. So first, we'll see the default options. So what I'm going to do is just hit preview. And with the help of this phase sorting step, you'll see it generates a nice color code. So what that color code shows is it tells what all surfaces will be on the injection side, and the other one will be on the ejection. Let's rotate this a little bit, and I'll zoom in and show you what it means. All right. Since we are in parting line command, so where is the parting line? The line, the white line which you see here on your screen, that's kind of dividing the part into two halves, is your parting line. So Solid Edge mold tooling has a couple of tools you can use in order to modify this parting line, and I'll show you that in a little bit. Now, everything looks good, and now it's very well integrated. Mold tooling is very well integrated inside Solid Edge. So by that I mean I can use all the capabilities of Solid Edge surfacing and modify, make changes, and bring that changes inside mold tooling. And that's what I'm going to do in a little bit. So I'll just hit finish, and now I can go inside Solid Edge and make some changes to the parting line, and you'll see how I do that. So for that, I just one thing to note here is you'll see this two Pathfinder. Now we have usually we have only one Pathfinder. Now you'll see there are two Pathfinder. One is the Solid Edge assembly Pathfinder, which you see on the top. The second one is a mold tooling Pathfinder. The purpose is very same, like it tells you which step of the mold tooling you are on. So right now I'm in parting line, so that's the most updated step, and that's listed on the top. So again, what I'm going to do is just add it inside the part, and that will open up in Solid Edge part environment. And here I'm going to use some surfacing capabilities to divide the face. So I'll use the split face command. This is very powerful. What I can do is just select the face, hit accept. Now I can give it a direction from where I want to split this. So I just say, okay, I want to turn on the reference plane for top, and I can use this reference plane here to split the face. So I can just select this face, hit accept. So it's going to divide this along to this reference plane, as you can see that. It divided all the three faces. I can go back to the mold tooling, and now since I made changes in the part environment, so the parting line is not updated. So what I can do is I can just hit kind of refresh or synchronize button. So what it's going to do is accommodate all the changes we have made in the part environment. Now, after doing this, since we have split the face, we have to tell mold tooling that whether I want to specify the face in the injection or ejection side. So what I can do is I can add it inside the parting line, and then just by selecting the face, what I can do is I can just specify the face on the ejector side or injection. So what I'm going to do is just select the face here, and now I can specify it as an ejection side. And you'll notice that the change, the color will change, and also the parting line will instantly update. All right. So now, you notice that the parting line, instead of going from the top, is just passing through the split face. All right. So this is our parting line step. So what I'm going to do is next step is called parting surface. And with the help of parting surface command, you can also make edits to your parting line. I'm going to show you that. So what I do is just select the command, select the part. It will automatically select the parting line, so you don't have to look for the line. Hit accept. Now, first I will just keep the default options. So if I hit preview, you'll see it's going to create a surface of the part. So it's not going to create any parting surface. What do I mean? Any outside surface or inside patches. So I'll show you some options which you can modify in order to get that. Now here, this tool is very powerful. Why? Because it gives you ability to change the parting line inside the parting surface. And how? You can just select. Maybe what I want to do is I want to connect some edges, create some new loops. So what I can do is I will just select this loop command, and then I can select this point and this one, these 2 points. So I want to create a loop and hit accept. And you'll see that I can just run. It's telling me to run an iteration. So I can just hit preview. And it's going to take that loop inside the parting line. So previously our parting line was going from the top, but here you'll notice that it's going straight. So because I added the loop, now I made some changes. I'm going to do this again on the other side. This time I'll add a loop inside this cutout. So I'll just say add loop and select these 2 points and hit accept. And now I can run this iteration again to accommodate all the changes. And by doing that, you'll see it creates external surface instantly, and everything looks good. One thing to note here is you'll see some internal patches which are not filled by this this parting surface, all these holes cutouts. So imagine how much time it will take in Solid Edge or any by using surfacing command to fill all this surface. So in mold tooling, what you can do is you can just you can tell mold tooling to fill all the inside cutouts. And what I'll do is I'll just say just patch the inside filling. So I'll just hit OK, and you'll notice that it automatically fills all the cutouts, all the voids inside the surface. So by doing this, I took care of the inside surface and also the outside surface. So our construction, our parting surface all set to go. All right, let me show you an isometric view here. All right. Now, the next step is called parting zone. So what we're doing is we're moving from top to bottom each column. So here, what we'll do is just select the command, and we'll select the part. It will automatically select the parting surface, and I can hit accept. Now, there are 2 options in parting zone: whether you want a rectangular or a circular parting zone. So you can specify as per your requirement. The other one is you can change the dimension of the parting zone. Just by clicking on this tab, what I can do is I can specify how much my width is, like in y direction. I can just say, okay, I want to make this as 160 smart enough. Even though I change it in the injection side, it automatically changes in the ejection side. It knows that all the plates going to be the same size. So I can hit OK, and now by doing this, I just created a parting zone. Now, once we have our parting zone, the next step is called mold base. So what mold base does is it creates a bunch of parts automatically for you, all the different plates, ejector plates, stuff like that. So, and also there is a standard parts inside that mold base command. So all you have to do is just pick the standard, and it will automatically put all the standard parts respect to the standard you select in the mold base. And I'll show you in a little bit. Before I do that, you'll notice that I have only one instance of this parting zone. So what if I want to create multiple instances of this parting zone just in order to save time and resources? Again, we have in mold tooling, there's a pattern command. So pattern command works very much like Solid Edge pattern command. So what I have to do is I have to just select the core and cavity set, hit accept, and it gives me a small command bar, and I can enter the number of instances in X and Y direction, and also I can give it a spacing. So in this case, I'll just say 0 by 75. And hit finish. And you'll see that it is going to create multiple instances of this parting zone. And it also created multiple runners for you on both ejection or injection sides. And that's in the middle. Now, what if I want to change the orientation later on? Like I want to change the orientation of any instance. So what you can do is you can add it inside the parting zone. And now there's a tab here that says Added Pattern Occurrence. So if I select this tab, you'll see the different coordinate systems they came up. This coordinate is nothing but showing you a part. So whatever the part I want to change, I can just highlight the coordinate system for that part, and I can just set a rotation angle. In this case, I'm just going to rotate it by 180 degrees, and hit finish. And you'll notice that the orientation of the part it changed as I click OK. Now the next step is I'll go back to the parting zone and create some insert integer plate mold. So all I have to do is just select this one occurrence, and it will do integer mold. So what is the integer mold? So now it's what it does, it removes some material of the part from the ejector plates. So remove and also add. So it's just a Boolean unite and subtract step. And I'll show you a little bit how it looks like on the ejector plane by hiding a bunch of planes. So I'll just hit finish and you'll see that it updates. Everything looks good. Now we'll go to our mold-based command. So now right now it's updating cavity, core plates. So it's removing, the Boolean operation is removing all the different material from the different plates or adding material. So the next one is called mold base. So all I have to do at this point is just select this, and there's a standard here. There are different standards. Now, whatever standard which you want to use, you can pick this standard. And also there are different types of mold bases, where you want a side gate or a 3-plate gate or a pinpoint gate. You can select the standard. And also in the description, you can just type what type of series of mold base you want. You can select the series, hit OK. And now you can just give it some direction, some size. So in the mold size step, what you can do is you can set the size. In this case, I'm going to make 600 by 750. And also in the plate management step, all these sizes, they're updated here. And these are the different parts which will be created automatically in this process. So before it creates, it gives you ability to change all the dimensions of the different plates. So all you have to do is just select the plate, and then at the bottom, you can change from 90 to 70 in the Z direction. And also you'll see there are a bunch of other stuff, material, call out, and also you can display the plate references in the below material, or you can add the selection. So at this point, I'm going to hit OK and hit preview. So it's going to create the mold base for you. And as we're doing this, you'll notice on the assembly Pathfinder, all these sub-assemblies, which we started off with one part, right? And now all these assemblies, all these parts, these all are solid edge parts, and all these parts are linked. I'll show you a little bit. So now once we have our mold base, what we'll do is we'll add some more standard parts for this mold base. So we can do this in just 2 clicks. And for this standard and for this mold base type, it is going to put some customized parts. And it's looking at the KLM standard, which I selected at the beginning. So right now it's creating all the different parts instantly. And I don't have standard parts installed on my machine. Everything was created in this section or in this presentation. It's done by mold tooling. So you don't have to install standard parts in order to create all the different parts here for this project. So I'm going to hide all the coordinate systems here, and you'll see there are a bunch of parts which were automatically created for this project in just 2 clicks. Now, once we have our mold base, so what I'm going to do is here is I will just create a new display configuration in our. So I'll just name it as top level. And hit OK. Now I'll create another one, and that display configuration will show you all the ejector plates and how that material, the Boolean operation was conducted in the parting zone step. So what I'm going to do is just run show only here. And then I will hide a bunch of components, bunch of parts on the top plane, all the pattern occurrences. So either I can use a selection manager, or in this case, I can just graphically select these and just say, I want to hide this. There are another occurrences on top of this part. So I'm just going to select them one by one and hide these. So this is how your core looks like. So in the parting zone operation, this is what was created. This is a core, this is your ejector side. So what I'm going to do is just create a new display configuration, and I'll name this as ejector. And hit OK. All right. At this point, everything looks good. And the next step, what we'll do is we'll have some injection channels. So how the plastic mold will flow inside these plates onto different occurrences, and we'll for that we need to create some sketches here. And what I'm going to do is I'm just going to create a parallel sketch here, onto the top plane, and I can place. You don't have to worry about the distance because it's going to project that as a cutout on the bottom plane. So distance can be anything. In this case, I'll just select some of the background edges as a reference, and then I'll just do some relationship and alignment. I need some, let me turn on some reference planes. All right, so a little bit of sketching is involved in this step, and this is nothing, and this is very customized in order for your requirement. So whatever injection procedure, injection channel you want, you can just have a linear sketch and be done with it. So here, what I want to do is I will just create a angle injection. So I'll just say minus angle, and then give it a line here. Everything looks good. Let me put some dimensions on it so that we know how far we are from the port. So I just select this one, this one. So from the port, we want to be at 5 millimeters. And here, let's say 30 and 25. All right, everything looks good. So I'm going to create multiple instances. In this case, I will rotate the sketch. So I can select the axis I want to rotate on. And while this is highlighted, I want this rotated on the other side. So what I'll do is just grab the sketch, and then I'll just say, okay, I want to rotate it onto the other side. Looks good. I just put this at the middle so that we have a symmetry. All right. So now you'll see all of them are linear elements, and these will act as an injection channels. So for cold wells, I need some circles. So what I'll do is just put some circles here. Circles on the injection channel. All right, looks good. Now, whatever stuff I don't want onto my cold wells or injection channels, I have to convert them into a construction body because it is a very automated process. Whatever it's going to look at the sketch, and whatever it finds solid, it is going to convert that as an injection channel. So in this case, now what I can do is I just convert some edges as a construction geometry because I don't want them as an injection channel, and hit finish. All right, our sketch is onto the parallel plane. So what I'm going to do is just select the command here for injection channel. I can select the sketch, hit accept, and now I can just preview, and you'll see that you have injection channels. Now in this case, I can give it a diameter. I'll just go by default, and also if I want to change the diameter, so by default I selected 6 mm. So now here what I'm going to do is just select some of the sketches where I don't want 6 millimeter as diameter. So I want these branches to be a little bit smaller than the main line. So in this case, I can just hit accept, and now for diameter I can just say 4.5. So the main line, which is going through the center, will be 6 millimeter, and the branches will be 4.5. And I can hit finish, and you'll see that from the ejector plates, the material is removed. Now imagine doing this inside your CAD environment. Now it will require a lot of sketching and a lot of precision to get this type of stuff. Now here all we have to do was just put a sketch parallel to the top plane and then select the sketch. So whatever was linear came up as an injection. So all the circles which I have, I'll use that for a different command, that is adding or editing cold wall. So for cold well, now we'll look at that later on. Now here what I'm going to do is just change, at this point I'm going to change this configuration to my default top level, and we'll add some gates. Now it's very easy. What I have to do is just right click on the injection and just say I want to add some gates. And it is so easy that you just have to select the endpoint here. So all I have to do is just select the endpoint, hit accept, and I can hit preview, and the gates will automatically be created. And I'll show you in a little bit how the gates look like. So gate is nothing but it's a connection between your injection channels and your different core. So it's going to pour that material from the injection channel onto the parts through this gate. Now here, I will have to change the display configuration to ejector side. And this is how it looks like. In order to show the gates, all right. So now what I will do is I'll put some cold wells. So now cold wells, the way you can create it is just by right click here, and then you can just do edit cold wells. Now I'm going to use a sketch which I created before, and let me check that sketch here. And now here I can select the circular circle. Now you'll notice that the selection criteria is circle 2D, so I will only be able to select the circles. And these circles will act as cold well. I can select the circle, hit accept, and now with the help of preview, I'll be able to create cold wells. Right now it's updating all the surface and the project here. And in order to see the cold well, let me zoom in and I'll show you the cold well, how they look like. Here you'll notice that you have a cold well on two different places, and it will depend upon your sketch, circle on the sketch. So you don't have to create this on the surface. There's a sketch which you did before. All right. That was all I had as far as mold tooling is concerned. Now, I skipped a couple of steps, and I'll show you which one I skipped. Let me move back to the top level. Now, I skipped three main steps here. So what are these steps? And one step is called splitter object. Now, this is a major step if you have a part which needs some splitter in it. So as per requirement, this part didn't need any splitter. So if you have that type of component, you can select this command, and you can select the part or the feature you want to act as a splitter, and then you can create your project. The second one is called cooling circuit. This is again very important, but the workflow of generating this is very similar to your injection channels. So what you have to do is you just create a sketch, and then you just select the project, and it will automatically create those cooling channels. Sorry. The third one which I skipped was this guy, place mold component. Now here, what you do is you select the command, and now you select the family, which family you want to add based on the standard which you selected. In this case, I said LKM. Now you can select what type of location, rings, bushings you want to put, and gives you graphic feedback. And also, if you know exactly, if you're looking for that database, there's a big database of different components here. So you can select in this database, you can just select whatever socket you're looking for, or taper pressure, which standard you're looking, and you can just select that part, and you can just place that onto your project. Right. This is that was all I had as far as mold tooling is concerned. Now, if you guys are interested in training, we have a training coming up next month, fundamentals, update, and also advanced level training. And we also train for mold tooling. And for all the training information, you can go to our website. And also, if you have any questions, comments, here's the contact information. This video will be posted on YouTube. Please call, email us if you have any questions, comments. Again, I hope this session was helpful. Thank you very much for your time.